In the final months of Hitler's Third Reich, at a remote airfield deep inside Nazi Germany, a top-secret jet fighter makes its first flight. This is the Horten 229, a Nazi weapon that might have changed the very outcome of the war.
The Horten 229 had to be the most exotic piece of machinery in Germany at that time.
But was it truly stealth?
It has been one of the last great mysteries of World War II.
Now, more than 60 years after it took to the skies,
1, 2, 3.
an elite team of aeronautical engineers and stealth experts
Yeah, we lost it. It's over.
reconstruct one of the Third Reich's most incredible secrets.
It's great, it's in.
Never moved a German stealth fighter before.
They'll put the Nazi flying wing to the test to unlock the mystery of Hitler's stealth fighter. In the final months of World War II, Allied forces speed across Germany in a desperate search. Intelligence reports suggest Hitler's Third Reich has a secret weapon that could change the outcome of the war. On April 14th, 1945, the U.S. Third Army discovers a top-secret facility hidden in the woods 100 miles northeast of Frankfurt. Inside, they find one of Nazi Germany's most advanced weapons, made almost entirely of wood.
The soldiers must have been stunned when those doors opened up, and for the first time they see this aircraft with its unearthly shape, something that no one had ever seen before, a jet engine-powered wooden aircraft. It would have been impossible for them to clearly understand the magnitude or even the importance of what they had discovered.
In July 1945, the Horten 229 and other advanced Nazi aircraft are shipped back to the United States under the codename Operation Seahorse. The Batwing fighter is reassembled, but its flying and stealth capabilities are never tested. For the last 6 decades, the only surviving Horten 229 has remained hidden in the shadows and away from prying eyes. Generations ahead of its time, the coveted Nazi war prize remains under tight security, along with other U.S. artifacts, here inside a government warehouse outside of Washington, D.C. 64 years after the Horten 229 took to the skies, the debate about its stealth capability is about to be settled.
Wow. It's amazing that the Germans were that far along in World War II.
It's amazing that of the technology that existed during the time frame, that they could come up with this type of a vehicle.
Stealth expert and aircraft designer Tom Dobrenz will lead a team from the aerospace company Northrop Grumman in building a full-scale replica of the Horten 229. Once complete, they'll then test its stealth ability against World War II Allied radar.
After the Battle of Britain, Goring come out and says, we need to find new flying machines. What we got now is ineffective. It wasn't ineffective. You know, they had some good flying machines. It was the radar that destroyed them.
Most of what is known about the 229 was gathered by David Myra during his meetings with the plane's designers, Walter and Reimar Horten, before they died in the 1990s.
Okay, Aldo, diameter of the exhaust liner.
The team has been given a few precious hours to examine and take measurements of the original German jet, a plane constructed almost entirely of wood.
Skin thickness, 3/4 of an inch.
The layers of veneer suggest the plywood may have prohibited the radar from penetrating the skin.
Was it truly something that they were trying to defeat a radar system? And that's going to be something we're going to try to find out.
To solve the mystery, they'll first test the plywood skin.
This will help us determine whether energy is being absorbed or reflected, or maybe shielding the inside of the vehicle itself from energy.
They'll use a pair of radar-emitting probes to focus electromagnetic energy against the plywood skin to see if it absorbs radar.
It seems like the surface itself isn't conductive, but it may be absorbing the signal.
So there's a good possibility that this could have been built as, if anything, maybe not even absorbing, but just possibly shielding.
The test confirms the wood improved the fighter's detection range, but it's not the only stealth feature on the Horton aircraft.
2.5 inches. It's got buried engines in the fuselage. All the surfaces are blended. You've got the carbon in the skin. You've got all these things. And then to say, you know, were they thinking about radar? Well, everything points to that.
This is the modern shape of stealth, the Northrop Grumman B-2 bomber. This expansive flying wing embodies both engineering elegance and all-aspect stealth. Although it spans more than 170 feet, its radar cross-section, the amount of electromagnetic energy it reflects back to the radar, is smaller than that of an eagle. To reduce its signature, stealth aircraft like the B-2 rely on two critical factors: materials that absorb this energy, and more importantly, a shape that prevents it from returning to the radar.
Stealth technology doesn't make an aircraft invisible, but what it can do is dramatically reduce the detection range, making it much more difficult to defend against using fighters and anti-aircraft weapons.
Modern stealth aircraft were developed by aerospace companies like Northrop Grumman in secret facilities starting in the 1970s.
A lot of the things that we've been doing over the years, you know, is kept in a cloak of secrecy. Most of the time, the things I work at Northrop are programs that I'm not allowed to talk about.
Much of that top secret work happens here, at the company's advanced design and manufacturing facility in the Los Angeles suburb of El Segundo. It's also where they'll build the Horton 229 over the next 3 months. While it won't be designed to fly, like the original, it will be a full-scale replica constructed around a center body flanked by a pair of outer wing panels.
Right now we're building the rotator, and
Tim Knott's model shop team begins assembling the center body from blueprints reproduced from the Horton brothers' original drawings.
Okay, let's stick it together.
Like the original Horton fighter, they'll use glue and nails to fasten the parts. While the shape of the replica is critical to its radar cross-section, or RCS testing, so are the materials.
Most of it is wood, and there's a few parts that are going to be made out of fiberglass. But the only metal parts are the rotator and the lifting points.
Gus Kindweiler and Tim Knott have spent their careers working on Northrop's most advanced stealth programs.
But they're not all the same.
They'll assemble the model's center body around a metal rotator. The majority of RCS models built by Northrop Grumman are classified. Most are destroyed after stealth testing is complete. The rotator is the only part that is reused.
This rotator box was used on a different program, another classified program. I really can't tell you what it is, but it's seen its fair share of action.
When complete, the rotator will be used to attach the model to a pole 5 stories above the ground. They'll then direct radar at the fighter to determine its stealth. The idea to build the original 229 a German aircraft virtually undetectable to Allied radar, was born in the aftermath of one of the most pivotal battles of World War II. In preparation for Hitler's planned invasion of Great Britain, in the summer of 1940, Hermann Göring unleashes the Luftwaffe with orders to destroy the Royal Air Force. But the British have a secret weapon.
What gave the British the defensive edge they needed was radar. This was a new technology that provided accurate range, altitude, and the numbers of German aircraft as they approached across the English Channel.
Britain's chain-home network of radar stations proves critical in directing RAF fighters who cut down the German invaders.
That was the one technology that completely alleviated the advantage the Germans had with their overwhelming number of aircraft. The Battle of Britain proved to be the pivotal point in the air war, and radar was the key.
In an effort to recapture Luftwaffe's supremacy, Göring envisions a new fighter, employing the latest in state-of-the-art German technology.
Officially, the concept was known as a 3x1000. That is, a fighter that could fly 1,000 kilometers an hour over a 1,000-kilometer distance and deliver a 1,000-kilogram bomb on target. It was pushing the limit of any known aviation technology of the day.
As members of the Hitler Youth, Reimar and Walter Horton became consumed with the idea of creating an aircraft that flew with the elegant efficiency of birds. In the early 1930s, the self-taught aircraft designers began building and piloting a series of tailless wooden gliders. To meet Göring's requirements, the brothers began modifying their flying wing around a recent innovation, the jet engine. If their concept worked, it promised to leave the Allies defenseless.
Walter and Reimar's brother Wolfram was killed in the Battle of Britain as Wolfram was laying mines along the French coast in Heinkel 111. Walter still burned with revenge for losing all his friends in the Battle of Britain, so he wanted to go back to England to attack the British chain-home radar network. The Horton 229 was a brainchild of Walter, and it was generations ahead of any other aircraft developed in the world.
Of the proposals reviewed by Göring for his new fighter, only one aircraft met his requirements. It was a radical design submitted by two brothers he'd never heard of.
The flying wing was a radical concept to everyone, including Göring. And the idea that it was made out of wood just added to his skepticism. Walter's so consumed with the passion for this plane that he sort of pulls Göring into the whole idea, saying, we can do it. We can build this from wood with jet engines. We can make it fly 1,000 kilometers an hour. We can give it a 1,000-kilometer range. We can deliver the payloads you need.
And Göring just said, I'm just astounded by this machine. And the shape, he says, no tail, no elevator. Walter said it's going to be so maneuverable against Allied fighters, Allied bombers. It's going to sweep the skies clean for you.
So Göring is so taken by Walter's vision that he buys in completely to a flying wing.
Göring said, go do this, build it for me and make it fly. The Hortons left the meeting with Göring knowing that they had won the contract to build the 3x1000 flying machine, and now they felt that they had been vindicated.
More than a half-century later, the team at Northrop Grumman begins constructing the wings for their Horton 229.
This is going to be a big model, over 50 feet wingspan, and we're going to need a lot of wood to build this model. We're trying to build it similar to what they built it back in World War II.
Even though it's only a model, they must ensure its shape and the materials used in its construction mimic the original aircraft for the radar testing to be valid.
Just painting the back of the wings is enough to represent the tanks?
Yeah, because actually at the frequencies and the wavelengths that these radars worked at, they were very long. And this was an aluminum metallic tank, and I think if we paint it with some conductive materials, it'll represent part of the structure of that tank to the radar. We're actually going to be painting in this back area here, and probably we will do some outside painting when the vehicle is fully assembled.
Now it's going to be getting it to stay, gluing it.
Tim Knott and the model shop crew at Northrop Grumman are one of the few teams in the world building new stealth concepts. They're an elite and eclectic group who spent most of their careers working in the shadows.
It's nice to have the chance to build these models, and then we see what they look like before they even come into production.
They'll construct the wings in two major sub-assemblies. First, they'll build a long curved leading edge, wrap it in wood, and then bolt it to the main wing panel.
It's being built in about a quarter of the time that a normal RCS model would be built. Usually this is a year effort, and we're doing this in, what, 3 months?
Give me a nail right here, because I know I'm good here.
I didn't even know there was something this advanced in those days, and I can imagine what it might have done to the war if they would have gotten successful with it.
Okay, ready?
Right now.
Start at the bottom?
Yeah.
Yep. Can't let go of this. It's popping.
Come around like
Yeah, keep going down.
The team at Northrop Grumman will use a combination of old-world craftsmanship and modern tools to recreate the 1940s flying wing.
We're using foam to manufacture the wingtip of the Horton aircraft. Machining it is just a lot easier. So by carefully controlling what kind of paint we put over it, it'll have the same radar reflective properties as the wood that it's mounted onto.
In little more than a week, they glue and nail together the 80 ribs that make up each of the outer wing panels.
We're simulating what would normally be the fuel tank in the Horton. This is real silver paint. It's silver suspended in a polyurethane coating, and it's rather expensive, about $2,500 a gallon. Okay, that'll look like 2 fuel tanks to radar.
Keeping true to the materials the Nazis used on the Horton 229, they skin each wing with plywood.
It's always great to see major sub-assemblies come together.
1, 2, 3.
A month into the build, they've finished the leading edges and are ready to bolt them to the outer wing panels.
Down a little bit, push it in.
But where there's wood, there's warpage.
There's a gap between the pieces because this piece of wood's warped out from the water. It looks like about a ½ inch.
There's always a little warping, but that's why these guys designed it, so they could put a bunch of the fasteners in afterwards and just take care of the warping to get a really good solid assembly.
We're just filling it in with resin and Cabosil, and we're going to put a layer of fiberglass on there.
To ensure there are no imperfections that will create unwanted radar reflections, the team spends hours in a cloud of fine dust, painstakingly sanding each wing panel.
When they're testing the model up on the pole in RCS, they don't like to see any humps or sharp edges at all, or gaps. Anything that it could be a rivet, it could be an edge, it could be anything, they'll get a return, and that's not good.
Northrop Grumman has a long history building wings. Like the Horton brothers, company founder Jack Northrop was convinced tailless aircraft would one day revolutionize military aviation.
Today is the day that one of us is going to lose our life to Texas's machine of death. David Martinez. It's his day today.
Man is capable of extreme engineering, but eventually, everything breaks down. I'm Sean Riley, and I'm joining the most elite repair teams on the planet for fixes that are expensive and dangerous on a monumental scale.
World's Toughest Fixes, a new episode every Thursday at 9 on Nat Geo.
More than a decade before the Nazis began working on their all-wing fighter, back in the United States, Jack Northrop was already flight testing flying wing designs of his own. After World War II, the Northrop YB-49 became the U.S. Air Force's leading contender as its first intercontinental bomber. Now, decades later, Northrop is recreating a flying wing with a much darker past.
Work myself into the model.
With the internal structure of the Horton 229 center body assembled, Gus Kindweiler and Jeremy Osborne get to work skinning it with plywood.
That's good right there.
We're using a flex board, wood that's not real strong, and the reason we're using it on the leading edge is so we can just use the one piece and wrap it around the bulkhead and the rib. I need a third hand here.
Like the finished outer wing panels, they'll construct the complex shape of the center body primarily of wood. To ensure the amount of electromagnetic energy the 229 reflects back to the radar is accurate, Northrop Grumman will replicate two of the most vulnerable areas on a stealth aircraft: the metal cockpit and the inlets. The engine shrouds flanking the cockpit will be fabricated by Bill Marsh and Mark Ferrari.
On the original plane itself, it was welded steel. This is made out of carbon fiber, which is a lot lighter, easier to lay up, simulates the metal.
To reduce the amount of handcrafted parts, they use a sintering machine to rapid prototype the engine turbine blades. The sintering machine is ideal for replicating complex, one-of-a-kind parts, capable of creating any shape by melting thin layers of powdered nylon.
And this type of technology is called additive layer, and what it does is you start out with nothing and you make only what you need. We grow this overnight and it's completely finished. All the holes, everything is there.
In less than a day, the turbine blades are finished and ready to be assembled. For the radar testing, they must ensure the nylon and fiberglass parts have the same conductive properties as metal.
In the area of the inlets, what we end up doing is we take a reflective paint and we coat the outside of the shape so that from the radar standpoint, it doesn't know whether it's a piece of fiberglass underneath or it's a piece of steel or aluminum.
I think in the 40s how the brothers made this canopy, they started off with a flat sheet and they bend, screw it, heat it up, and just keep bending and forcing.
The cockpit of the 229 is a big opening and vulnerable to radar. Modern stealth aircraft use special coatings on the canopy to prevent electromagnetic energy from entering the cockpit and bouncing back to the radar. In order to keep the replica faithful to the original aircraft for its radar testing, the team decides to use 1940s material and techniques to form it. But it's a complex shape, and time is running out.
This part and this part.
How do you say 1, 2, 3 in German?
Eins, zwei, drei.
You want to just get one side of this thing? Yeah, we lost it. It's over. It's over. It ain't gonna work no more. We're done.
We're gonna have to give it another shot. We're gonna cut this out so this area is relieved, and then this will lay down a lot better.
After reheating the plexiglass, the team makes a second attempt to shape the canopy in one piece.
Yeah, we've lost it. We've lost it. Okay, nice effort. Nice effort. Open the one door. Open the door. Open the door. We're not going to give up. So what I'm going to do is I'm going to do it in two pieces. I'm going to eliminate half the problem.
With the inlets and nozzles metallized, the team pushes forward to complete the center body.
The radar is coming in this direction because the plane is heading towards the target. So the radar is coming in at this angle, and you have turning fan blades here that reflect the radar. So this is a very vulnerable area on the aircraft for RCS.
When I get out of here, Mark, let's start working on these nozzles and put the foam in them.
Clockwise.
Right there. I don't think we need to move it other than to paint underneath it.
I think we're ready.
They attach the carbon fiber engine shrouds to both sides of the cockpit. Like the wings, the center body is filled and sanded smooth to ensure the shape of the model is as close to the original aircraft as possible. With the plexiglass now cut in half, Steve Simpson makes another try at forming the canopy.
Yeah, I think this might work. This is happening good. Okay, somebody get in the middle quickly.
You see that we have a shape? I think it's success. I just polish that sucker with a buffing wheel and it'll be nice. I think the Germans did the real one in 2 pieces.
Push it forward, east. Right there, that's good. You're good. Go a little more north. It's great, it's in.
With the outer wing panels attached, the last component of the center body is ready for installation.
Yeah, I'm in the hole, go ahead.
Using a litany of materials, including the plastic pipe you might find under your kitchen sink, Gary Heathcote has built an accurate cockpit of the German fighter.
Okay.
Something.
Look at that, man. Having this all correct is really good because it's going to have all the correct surfaces for the radar to come in and reflect off of. So we really have a true representation of the real plane.
With the cockpit and canopy installed, the team undertakes one last step to ensure the plane is ready for radar testing.
This paint is supposed to simulate real metal because we want this to be exactly like the real aircraft was. And right now I'm checking the resistance here of real metal, and then I'm coming over here and comparing that to the metallized area we've painted, and they're identical right now, and that's exactly what we wanted to achieve here.
Although assembly is complete, the team has less than 2 weeks to paint and finish the replica before its radar testing is scheduled to begin. 64 years earlier, at a secret hangar deep inside Nazi Germany, the Horten 229 was being readied for its first test flight. At the top-secret Sonderkommando 9, the Horten brothers are overseeing preparations for the first flight of their stealth fighter. The war is about to enter its 6th year, and Allied bombers continue relentlessly pounding Nazi Germany. On June 6, 1944, Hitler's grip on Europe suffers a crippling blow as the Allies land on the beaches of Normandy. By the fall of 1944, work on the 229 is nearly complete when the Hortens receive word that the Fuhrer is now desperate for a long-range bomber.
Adolf Hitler had a dream of taking the war to the United States and would describe in detail to confidants like Speer how he dreamed of destroying cities like New York, to knock down the skyscrapers, to leave them in flames.
Reimer spent 3 weeks in December of 1944 designing the intercontinental bomber known as the Horten 18. It was going to be an expanded version of the Horten 229.
As the brothers work in seclusion on Hitler's America bomber, Their flying wing fighter is about to make history. December 18th, 1944. Just before dawn, pilot Erwin Ziller watches as the ground crew rolls the Batwing fighter from the hangar. Although a highly experienced test pilot, this will be the first time a jet-powered flying wing has ever been flown.
The Horten 229 was generations ahead of any other aircraft developed in the world. And the Horten 229 had to be the most exotic piece of machinery in Germany at that time.
In the frigid winter air, Ziller nudges the throttles forward and begins his takeoff roll.
When the 229 flies for the first time, it's vindication and validation for the Hortens. And ironically, the brothers aren't even there to see it. They're busy working round the clock on their design for the America bomber.
In January 1945, Walter Horten returns to Berlin to brief Göring on the brothers' design for a long-range bomber, the Horten 18.
Walter shows Göring the concept, a bigger version of the 229. 142-foot wingspan, 6 jet engines. Göring is stunned. In their conversations, Göring was very clear to Walter that he needed this new aircraft because by 1946, Germany would have a functioning nuclear weapon.
While the Hortens' attention focuses on their flying wing bomber, test flights of the 229 continue.
Over the following months, Ziller flew the Horten 229 numerous times, and it performed way beyond the Hortens' expectations. In fact, Ziller even flew it in a dogfight against the Messerschmitt Me-262, and it outperformed them in dogfighting ability, maneuverability, and speed.
While the flying wing uses the same jet engines as the Me-262, its new propulsion system lacks reliability. On a test flight in February 1945, Ziller's right engine flames out. Unable to regain control, he crashes the crippled fighter into the German countryside. Exactly 2 months after his first flight in the 229, test pilot Erwin Ziller is dead. After a grueling 3-month build schedule, the Northrop Grumman team rolls open the doors to its classified model shop and gives employees a chance to see the Nazi fighter firsthand. No one's more excited to show off his creation than Tim Knott.
All right, so here it is. It's done.
I tell you, you guys got to be proud of yourselves what you've done. I mean, this thing looks absolutely fantastic.
Well, thank you. We're really proud of it.
Among those interested in the all-wing fighter are the designers of Northrop's B-2 bomber, Irv Walland and John Cashin.
You did a great job. I tell you what, there's nobody better in this business than you guys.
After working 28 years in the dark, it's nice to spend one day in the light, you know?
You know, most of what we're doing here over the years never sees the light of day, you know, but it's nice to let people see what goes on.
You don't get the opportunity to work on something like this with history behind it, and that's what made it a little bit special. The other thing is that it's got my heart and soul in it. There's a lot of me in there. I can't wait to see it up on the pole. I want to see what it can really do. I want to see if it's stealthy. It looks stealthy. Certainly looks stealthy.
Finally now we'll get some real answers, some real data that will tell us, you know, how stealthy it really was. So that's awesome.
In a remote part of the Mojave Desert sits Northrop Grumman's Tejon test range. Built in the late 1970s, its numerous dishes can precisely measure an aircraft's stealth capabilities. From these inconspicuous hangars have emerged a stunning array of stealth designs. Security is incredibly tight, and access is granted to a select few. This is the first time cameras have ever been allowed at this desolate test site.
These surfaces that we've been working on are going to taste electromagnetic radiation pretty soon.
This is the first time radar's going to be shot at this aircraft, ever.
Okay, stop.
And I'm on to the coastal.
This is it. This is the day we've been waiting for. Great weather. Can't beat this.
I've moved a lot of stuff, but never moved a German stealth fighter before.
Yeah, we're good. We're good.
Awesome.
This is the first time we're actually getting a feel for what it looks like, as if it was flying.
While it won't actually fly, the 229 will be mounted 5 stories off the ground, so radar can be directed at it.
I'm just at a loss for words. This looks so cool. It just changes the whole perspective to see it that far away and up in the air.
With delicate precision, they lower the German fighter onto the RCS pole. 3 months of work hang in the balance.
Looks great up there.
Oh, it does.
As far as stealth characteristics and everything, we always, as an American, I feel like that's our deal, you know. We're doing the stealth stuff. Never had any idea that the Germans were doing a wing back in the 40s.
It looks great, it really does.
Time for the moment of truth.
6 decades after the first flight of the Horton fighter, the legend of its stealth is about to meet reality. Deep inside a secure control room on the edge of California's Tehachapi Mountains, the Northrop Grumman team is about to do something the Nazis never did.
Hey guys.
Hey Tom.
Test the stealth
Great.
of the Horton flying wing. To get a complete picture of the fighter's stealth capabilities, they'll rotate the Horton 229 to illuminate it by radar from every angle.
We're doing pretty much level and nose on the first set of spins. Each rotation does a frequency band. We're doing VHF, UHF, and L band.
This wide range of frequencies will give DeBrentz and his team a better idea of the fighter's radar cross-section.
So we want to make sure that we get enough of that data in order to characterize in each one of those systems how the vehicle performed.
Okay, we're starting our next spin now.
At this frequency, you can tend to see a lot more of the characteristics of the inlets and the canopy area up in the front of the vehicle. The inlets specifically, you know, where energy is going down and hitting the front of the engine frames is showing up, and the bow frame and the canopy, and just energy that's getting into the cockpit area and rattling around itself.
They want to determine if the Nazi fighter could have indeed penetrated the radar array along the British coast, known as the chain home system.
And I'll be really fascinated to see how, after we process the data and get some numbers, what the performance of this aircraft really would have been like against the chain home radar system.
Yeah, we have to do a lot of post-processing in order to get the actual numbers that we can use for comparison against the fighters and bombers of the day.
We're ready to go.
47 and number 74 squadron.
Inside their advanced air combat facility, Northrop Grumman can test the capability of nearly any aircraft in the world.
Altitude 22,000 feet.
All groups are reporting good scores.
It's here they'll conduct the second test on the Horton 229, flying it in a simulated attack on Britain and hitting it with Allied radar to determine its stealth.
4 systems that we configured, and we have been
Flying the jet will be Paul T.P. Smith. T.P. was the chief test pilot in the competition to build the U.S. military's newest stealth fighter, the F-35.
Roger, I've got altitude 20,000 feet, 600 knots.
T.P. will approach the British coastline from a variety of altitudes. His target, a chain-home radar station.
Fighters are in the air and on intercept vectors.
In the Battle of Britain, chain-home radar system, the low system, had a range of about 100 to 110 miles, which could see across the channel and into France. They could see the German fighters marshaling before they ever crossed the channel.
To help reduce their detection range, German aircraft began flying across the English Channel at altitudes as low as 50 feet. But by early 1945, any chance for a German victory had been lost. By mid-April, the Allies are closing in on the Nazi Sonderkommando 9. Although they've nearly finished a second Tu-29, the Horten brothers flee, leaving behind their dream of arming the Luftwaffe with flying wing fighters and long-range bombers. 63 years after the surviving Horten Tu-29 was discovered by the U.S. Army and shipped back to the United States, the Batwing fighter begins to reveal its secrets.
Is that the canopy there in the center that's lighting up, or is that just a blending from the inlets?
Well, it's probably a combination of both. Again, when you get down to these type of wavelengths, a lot of the scattering elements tend to blend together. So you can see that the nose, the inlets, that canopy areas, that's where a major part of the radar reflection's coming from.
It looks like with all the data that this aircraft would have made a major difference.
All about a 20% reduction in the actual detection range.
Once detected by radar, a conventional fighter of the time approaching at high altitude takes 19 minutes to reach the target. With its stealth and speed advantage, the Horten Tu-29 covers the same distance in less than 8 minutes.
While the Horten's advantage in detection range is on the order of 20%, the combination of speed and stealth was absolutely lethal. But even if you did detect it, it was so fast it would have been extremely difficult for any of the Allied fighters at the time to have been able to catch it.
You can imagine the amount of improvement that the Horten Tu-29 could have given to the German warfighter. I surely wouldn't want to have been the Allied forces.
Had the Tu-29 adopted the low-level tactics employed by the Luftwaffe, the results could have been devastating.
When you're flying at 50 feet, traveling at around 600 miles an hour, plus the reduction in the detection range, now you've got only 2.5 minutes of reaction time for the Allies to know you were coming.
Looking at it, your response time then with low altitude, when you only have 24 miles, that's 2.5 minutes, you just don't have the time to respond.
You could keep them from seeing you, and getting their defensive systems up, you create such an element of surprise. You can now basically roam at will and attack the targets that you want to.
The Horten Tu-29 aircraft design predates modern stealth technology by more than 3 decades. If the Germans had deployed it in great numbers, it would have been a game changer.
After decades of speculation and debate, Northrop Grumman has finally unlocked the mysteries of the Nazi stealth fighter. But the Tu-29 wasn't the only Horton stealth aircraft ordered into production.
The characteristics and things that we saw on the Horton 229, which would translate directly to the Horton 18, which was the larger version of the Horton 229.
Goring was very clear that by 1946 they would have a nuclear bomb, and the Horton 18 would be used to deliver that bomb on an American city like New York or Washington.
Even if you managed to detect a Horton 18 bomber approaching the east coast of the United States, you probably would have only had about 8 minutes of warning time, which would have been totally inadequate to mount any kind of defense against it.
While the stealth flying wing would have been a lethal fighter, its use as Hitler's long-range bomber is unthinkable.
It's a terrifying thought in a lot of ways, because if the Third Reich was able to use them operationally before the Allies understood they were there, those first few strikes with those airplanes could have been devastating.